And we will now evaluate our third differential equation using power series. And we have the values of y prime, and y double prime. And now our first step in solving differential equations using power series, we'll now first substitute the values of y into our equation. And having this, we have summation of, we have y prime and a sub n t raised to n minus 1, where n is equal to 1 to infinity, plus 2 the value of y, summation of a sub n t raised to n, where n is equal to 0, and which is equal to 0. And this is our equation after substituting the values of summation expression into our differential equation. And now, in order to evaluate the said equation, we must set the values of index into the same value. And in order to balance our equation, we will diminish 1 to our t on n minus 1, so that n will be equal to 0, and we'll add up 1 to our n a sub n in order to balance the expression. Having this, we have the summation of n plus 1, since we'll decrease 1 or we'll minus 1 to our expression, we add up 1 to balance this, a sub n plus 1 t raised to n, where n now is equal to 0, plus 2 summation of a sub n t raised to n, where n is equal to 0. And this expression is also equal to 0. And now we have balanced, we have shifted the values of n into 0. We can now evaluate the summation expression. And having this, our next step, we will factor the expression into t raised to n in order for us to come up into our recursion relation. Having this, we have n plus 1, a n plus 1 plus 2 a sub n. We have factored out t raised to n. And from this expression of n plus 1, a sub n plus 1 plus 2 a sub n, factored out t raised to n, we can now have our recursion relation. Having this of a n plus 1 is equal to negative 2a n over n plus 1. Using our simple ways of algebra, we have come up to our recursion relation. And after we have our recursion relation, in order to build our series, we will substitute values of n. And here we have substitute n is equal to 0. We have c sub 1 is equal to negative 2 c 0 over 1. When we substitute 1 to our n, we have c sub 2 is equal to negative 2 c sub 1 over 2. And since we have the value of c1, which is negative 2 c 0 over 1, we multiply this to our c2, having 2 raised to c0 over 2 factorial. And having the value of n equal to 2, we have c sub 3 is equal to negative 2 c2 over 3. Substituting the value of c sub 2 is equal to negative 2 cube c sub 0 over 3 factorial. And having the form, evaluate we have substituted values of n to our Croatian relation, we can now have our general equation, in which we have c sub n is equal to quantity negative 1 raised to n times 2 raised to m c sub 0 over n factorial, where n is greater than or equal to 1. And we have come up to our equation involving summation is equal to c sub 0 summation of quantity negative 2x raised to n over 2 factorial, where n is equal to 0 and to infinity. And this form is equal to our transcendental function, which is c sub 0 times e raised to negative 2x. So we have evaluated our differential equation y prime plus 2y is equal to 0 equal to c sub 0 e raised to negative 2x by power series, as we start from a value of 0 up to a infinity. So from this, we have evaluated the differential equation by a finite sum of polynomials. And that is our discussion about power series. And this is your awesome Yellow Corner signing off.